class of data structure DIT 2314. We start our class with the first topic, the introduction to data structure and algorithm analysis. Okay, so during this topic we will discuss about the fundamental of data structure, and we have the core definition of data structure. Okay, so the data structure itself is the systematic way of organizing and storing data in computer memory for optimal use. Okay, so our primary goal here is to enable the efficiency of accessing, retrieving, and also modify the data from its stored information. And the fundamental concept of data structure is the data items, the relationship, the permitted operation, and why data structure is important. In real world relevance, it can form the backbone of software engineering, designing database design, and the operating system. Okay, so the need and the importance of data structure in programming. Number one, we have the data volume management, that able to handle a massive amount of data efficiently and as the application scale, and also the processor optimization, able to reduce the CPU cycle required to locate and manipulate a specific piece of data. We want to see the memory efficiencies. Okay, able to minimize the memory waste throughout the optimized allocation and storage strategies. Okay, and also we need to manage the problem solving framework, able to translate the real world logic into structured computational model. Okay, so this is the structure of basic structure of data structure. We have the linear and the non-linear classification of data. Okay, so for a linear definition, linear means the element of the data is arranged sequentially or linearly. So each and every element in the data is connected into the previous and the next data. Okay, and the linear data example is like array, linked list, and stack and queues. Okay, this is in the programming data structure. Okay, and the second classification is the non-linear. It is the element of the data that arrange in hierarchical and interconnected network for each and every data structured. Okay, so we have two type of linear, non-linear data, which is the tree structure and a graph structure. This both able to handle the complex relationship of organizational charts of or a map. Okay, and then we have a primitive and versus the non-primitive data structure. So primitive data structure is basically basic data types that directly be used in programming language. Okay, for example, like integers 1 2 3 4 5 numbers, and floats 0.1 0.01. Okay, floating numbers, and characters ABCD. Okay, so this is all basic data structures, primitive data structures. And what is the characteristic of the primitive data? It is directly operate on a machine level instruction. Okay, and it occupied the fixed memory size. Okay, and then we have the non-primitive definition. This is more sophisticated, derive the data structure and created by combining a primitive type. Okay, so the characteristic of a non-primitive data types, the capability of storing collection of values and complex relational data, and also it has a a fixed memory size. Okay, the memory size is able to be adjusted. The concept of abstract data types, ADTs. Okay, so what is the ADTs? It is basically a mathematical model for data types that defined by the behavioral from the user point of view. Okay, we have encapsulation. So encapsulation is the technique to hide the internal implementation details of the data and expose only a clean set of operation. And we have a separation and of concern. This is separate when what is the data structure do from how they are implemented in code. And it also the ADT also depends in a language that can be implemented by using any programming language. Okay, C++, Java, or Python. Okay, so this is the concept of ADTs in data structure. Okay, some common example of ADTs. So we have a list ADTs. So this is maintains an order of collection and element supported insertion, deletion, and transversal. Okay, so the list ADT, as you can see from the diagram, is one of the in programming we use as a get in integer index, insert functions, and remove functions. Okay, next we have the stack ADT. This operates on a last in first out policies, meaning that it restrict the additions and removal to one end. Okay, so some of the example is like a push method, pop method, and peep method. Okay, and then we also have a queues ADT. This is operates on a first in first out FIFO policies. Okay, so adding the back of removal from the front. Okay, the example like NQ method, the queue method, and peak method. Okay, and additional ADT example is the map ADT. The map ADT associate unique keys with specific value for fast lookup using dictionary pattern. Okay, algorithm analysis. So what is algorithm analysis? It's the process of determining the computational resource with time and memory required to execute an algorithm, and it also focuses on a hardware independent metrics instead of focusing by using the clock speed or the execution seconds. Okay, and the predictive modeling allow the developer or the programmer to predict how the algorithm perform as input size increase indefinitely. Okay, and we have a comparison or comparative metric that provide a standard mathematical basis to choose which one is the best algorithm for a specific problem. Okay, and a space complexity fundamental. So space complexity is the total amount of computer memory consumed by an algorithm as the function is in the input size. Okay, so you give the algorithm or function an input, it will consume the memory to process the input, and it will able to produce the output. Space complexity also based on a fixed space and a memory requirement that does not depend on input size. Okay, and the variable space memory that grow proprietary with the input size, such as the dynamic arrays. And our goal here is to optimize the space complexity fundamental.